Our next set of topics is dedicated to controlling the logic of our program. So we're going to go over this presentation and discuss various types of jumps, including conditional jumps, and also formally introduce anonymous labels. So as you already know, program logic becomes more complex. We need to be able to check various conditions, and based on the outcome of the condition in assembly program, we have to jump to different places, alternative places, to handle outcomes of the conditions. The program also may need to repeat a sequence of instructions a few times. So that's a common loop situation. So in high-level programming languages, we have loop constructs and if-else constructs to handle various conditions. And in assembly program, we have to rely on CPU flags and jump instructions. And jump instructions basically direct the CPU to update the value of instruction pointer, which is the address of the next instruction to execute. And so the next instruction, of course, will be loaded from the target offset in the code segment. So to experiment with the code in this handout, I would like to clone our first assembly program project right here, which I still have on my system, which is week 5. If you need to refresh your memory how to create a project that is capable of assembling assembly code using Microsoft Macro Assembler, you can check instruction for assignment 5, first assembly program, and in fact this is what I'm going to do to start with, just with this blank program. So here I have week 5, which I'm going to copy and paste directly in my project subfolder and rename this to be week 9. Okay, so once I do this, I just go into this subfolder and I'll use this location to open my project. So this is week 9 right here, and this is the solution file. I open it. The usual thing to complete renaming the project is to go to Solution Explorer and rename the name of the solution. We can also rename the name of the project. And the source files, we have week 5 ASM, so I'm just going to rename that as well, so that there is no confusion about different source files and different project subfolders. So this is the result of experimentation during that specific week. So now we can update this with just a basic form that just defines the main function right here, main procedure, and so that's the starting point for our experimentation today. And if you want to refresh the options that we changed in the project settings, this is the name of the video that we've used. It was video 5.5, first x86 MASM project options. So check this video if you want to refresh your memory regarding the project configuration and project options. So this is going to be our week 9 ASM, and this is going to be discussion about jump instructions and controlling program flow. Okay. So the first topic to talk about is unconditional jumps. Basically, for unconditional jump, you need to have a jump instruction. It looks like this. This is the mnemonic of the jump instruction, and we can have a label, and label is specified inside the code segment like this. Okay, so this is the label, and label has to use the colon in its syntax. So here we can have whatever, we can have more code over here written, but whenever we hit the jump instruction, the instruction pointer will change to point to this label in the program and will transfer control to this specific location. So as we continue developing different programs in our laboratory exercises, we'll see the application of jump instructions in those projects. So a few highlights regarding unconditional jumps, which are achieved by using this jump instruction right here. Essentially, assembler determines the smallest encoding possible for the direct unconditional jump. This means that in the flat memory model, we can have, theoretically, we have a program space in 32-bit platform. We have a space of 4 gigabytes of computer memory. So, of course, transferring control to near location or to a far location may require more computation sometimes to determine the new position of the instruction pointer. And in that case, the assembler will choose the best format for the jump instruction. Essentially, assembler has to determine the correct distance of the jump, because once again, if there is more code written between the jump instruction and the destination of the jump, the target label for this jump, of course there is some distance in memory where we need to jump. So let's just try a few, we'll fill the no operation instructions here, just a few of the no operation instructions like this, just to see how this looks like in the disassembly window. By the way, sometimes when I load the project the first time, if I deleted prior settings of the project, it flips over to x64 configuration, just like I have it right now. Of course, this will not compile because this is 32-bit assembly. So we're going to switch that to x86. Okay, so if you're getting strange errors, just check this area to be sure that you're in x86 configuration. And so let's now build. So again, this is just a do-nothing program that just looks like this. And what we can do is we can, for instance, say step into, which will stop on the first instruction that belongs to our application code, like this. And so right now it's just started. You can see that it's telling me that it's just about to start executing this instruction. Of course, it may be a little bit more interesting to peek into disassembly. So if you right click anywhere in the source file and go to disassembly view, so this is what it looks like in the disassembly view. So now we have the address of this jump instruction, and this is its encoding. So remember when we talked about this correct distance of the jump, what it's just about to do is going to jump 7 bytes forward in our specific case. So this, if you count the number of no operation instructions, which are basically byte codes, 90. 1, 2, 3, 4, 5, 6, 7, exactly. So it's just going to jump over 7 bytes following this instruction in memory, and that's the location of the new instruction to execute. So we basically should end up, if we step over this, debug, right? So we're just going to step over this instruction, and this is our next instruction, which is the return instruction, return from our main procedure. And similar view, of course, you can have in the actual source file. So unconditional jumps to labels are relative jumps, just like we observed with 7 bytes in our situation. It was forward 7 bytes. Each relative jump instruction contains the displacement of the target from the jump instruction itself. This is the displacement right here that's placed, a byte-sized displacement that's placed inside the jump instruction itself. So the displacement is a signed number. Okay, so it's positive for forward references and negative for backward references. So these are just the highlights of the basic unconditional jump instruction, and these are all other details that you can read about this instruction. We can also use an indirect format for unconditional jump. So let's experiment with this. Okay, so I'm just going to say debug, stop debugging, and take a look at indirect operands.